Welcome back, students. So we are still working on the 2020 foundation level maths paper. We're jumping on to question 5 now. Okay, so first thing we notice about this is that there is no visual to go along with the question, so we'll have to be extra careful as we're reading the question and trying to model and understand what's the situation and what's being asked of us. So let's read. Cliff has an aquarium. So hopefully you know what an aquarium is. In case you don't, they tell us what an aquarium is. It consists of a tank of water and fish. Okay, and he has this aquarium at home. He needs to know the weight of the empty tank. So he needs to know that weight of the empty tank. So let's just draw an empty tank, and let's use the letter T to represent the variable for the weight of that empty tank, but does not want to remove the fish. Okay, so let's put a few little fishies in there. Fishy swimming around there, okay, and he's not going to harm the fish. Good. He weighs the tank when it is full of water. Okay, let's do a drawing of that. Okay, he weighs the tank when it is full of water and it comes to 11 kilograms. Let's just use the letter F for that. We'll see how we get on as we go along with our model. Okay. He then removes the water from the tank until it is exactly half full, and it now weighs 11 kilograms. So what I'm going to do here for representing the situation is we're going to draw a line through the middle here, okay, and maybe another line at the top. And so we know that, or we might even remodel that, okay, with the half the water. Okay, and that comes to 7 kilograms. Let's write in some values. We have 11 kilograms here, we have 7 kilograms here. Let's call that H for half. Okay, so maybe I'll get rid of the fish, they're not important, apparently. What is the weight? The weight of the fish is very small, so they're called negligible, or they don't really contribute enough to be worth calculating in. So we get ignoring the weight of the fish. Okay, so the best approach to this problem solving, so here's the question mark, how much does the tank weigh? And when you're problem solving, your best approach is to find out anything you don't know. That's one very clever approach. So if we can start to unravel the question, we might eventually end up with the tank, because it's not obvious at the beginning how to get the weight of the tank over here. But what is easy to find out is the weight of half of the water. Because if we subtract these two values, subtract the right hand side away from the left hand side, of course we get 4 kilograms, but we also get half the weight of the water. Okay, this black hatched area, volume here of water. So we double that to 8 kilograms. And it's okay just to kind of doodle along yourself and write things down as your logical thought takes you to different places. So now we know the entire mass of the water is 8 kilograms. I could kind of represent that. Well, we could drop the water in here now and say, you know, the water alone is 8 kilograms, while the entire tank plus water is 11 kilograms. Well, that's it solved now for us. We now know that the tank, why am I doing that? 11 kilograms. We now know the tank is the 3 kilograms difference. So the tank T equals 3 kilograms. Okay, now we didn't use simultaneous equations, which we could have done, because that would be kind of overkill for the situation. If the situation was simple enough that we could use our knowledge of number, indeed we didn't need to introduce any letters, so simply doing our sums with number and mathematical operations was enough. That's the end of question 5a. Okay, I'm just waiting for this to synchronize. Okay, so now we're on to what looks like a triangular dilation question. So I'm going to explain this to you as we go along. So first let's read the question to see what we're being told. In the diagram below, X, Y, Z. Now this is very abstract, so you've got to force yourself to try to go through the story from X to Y to Z. So that's that triangle, starting here, heading that way, and then heading that way. is the image of ABC. So what I like to see is they're going around the triangles in the same way, with the same corresponding path. Okay, so it's an enlargement with a scale factor of 4, meaning every length is correspondingly 4 times longer. So putting things simple, everything is getting multiplied by 4. Every length is getting multiplied by 4. Okay, that's the situation. So for instance, this length here will appear in here 4 times. 1, 2, 3, 4 times, etc. Okay, let's go answer some questions. We know the situation. We understand the problem. So now we're told that AB is 2 centimeters and we're asked to find XY. So we want to see that visually, understand that AB and XY. Well, there it is there. Here's our AB. So we're told that this is actually 2 centimeters. So we can add that to our model. And then the question is, what's this? Well, we see we have to multiply everything by 4. So the answer is simply 4 times 2 centimeters. So the answer is 8 centimeters. Great. Next up, we're going to talk about angles into dilation. So the angle at A, in a triangle, they're not so complicated that you've kind of, it's shapes like this, compound shapes, where if they talk about the angle at a point, you have to really consider what arms are they talking about. So in a simple triangle, it's enough to just think about the letter itself. So the angle at A is 60 degrees. What's the angle at X? So let's have a look. Well, one of the things we know about dilated or enlarged triangles is they're similar. And the special thing about similar triangles is all the corresponding angles are equal. So it's really simple. You don't have to do any calculation. You just have to say the answer is also 60 degrees. Okay. And finally, the area of the small triangle is 1.5 centimeters squared. What's the area of the large triangle? Okay. So the area here is 1.5. Now, a bit of careful thought here, and there's a big mathematical concept that you need to know at the end of your course, and you can learn it right here. It's this: if you multiply the lengths by 4, and you can get an idea, there'll be another corresponding length, say, I've used red, I'll use blue here, 1, 2, 3, 4, sorry, 1 here, there'll be 4 of them here, etc. And one of the properties of area is that it's scaled up times the scale factor squared. Okay, it'd be particularly easy to understand that if there's a rectangle, but it's also true of a triangle. So the area is enlarged by 4 squared, which is 16. So we're going to times 16, 1.5. Okay, or that's your calculation, which is this, which is 24 when you put that in the calculator. So the answer is 24 centimeters squared. And that's the end of that question as far as I know. So as always, students, I will see you in the next one.